Hello, it's Dr. Hill here. And last prep you didn't do too well in moving vectors onto a real body diagram and then moving those vectors around to work out what resultant was. A lot of people suffered a lot of strife. So the very first thing you start off with is a body, and you could call it a car, a person. It's best and easiest to give it a single letter. Here I've called it capital A. In the diagram it's going to be a small a. And it's best also to know its mass, and in this case it's 10 kilograms. So the first thing is you draw a body. In general it's a circle or a square, but it's a light pencil or dashed outline indicating that it's a symbol but actually not part of the actual mathematics that you're looking at. What is part of the mathematics is the centre of mass, COM. Drawn at a drop at the centre, and COM is standard physics or science parlance. Everyone knows what it is. In New Scientist, they no longer write centre of mass, and a lot of scientific magazines they just write COM. Everyone knows what it is, and you label the body. For you, it's a very fine pencil line and an A, any indication of it directly. You then record the data. Notice that I have the equal signs and the decimal points all lining up. In general, it's best to draw two lines ahead of it. And this way, I've always got the units here. Now, in general, you'll be told 50 or 75 newtons from the text. So to just write down what exactly you are told from the text. Then after you recorded the data, the first vector you always add is a vector due to an external field. In this case, it's the weight vector due to gravity. So that's there no matter what happens. So weight is only a product of m and g. It's got a special symbol W. Then you add the other vectors. In this case, I've got an N and an S, nice different colours. Then we've got a body diagram, and we have to move that body diagram to a vector diagram. This tells us that all these vectors are acting on this body. Now for HSC and for us, we have all the vectors acting on a single, or what we call a rigid body, and they're all acting on the centre of mass. And in fact, string may well be acting at a point on the mass. Say you can imagine it on the right corner, and the north or the reaction force, which is typically called N, may be from the surface. So this is basically where physics is unrealistic, but we do it just for simplicity. So what we do is that we get rid of the body diagram and redraw it, where we keep the orientation and length of the vectors the same, but move the vectors around the place. So notice that the vectors, by not changing size or orientation, still have the same horizontal and vertical component. And now these obviously do not add up to 0. You could go down the W, up the S and up the N, or you can get there straight with the resultant vector, which is now blinking. Now, just looking at that, that's resultant vector. If the north vector is, or the N vector is 50, that would be about 10, and 10 newtons acting on 10 kilograms will accelerate 10 kilograms roughly about 1 meter per second. So we know that this object will be accelerating at 1 meter per second.